Okay, imagine this for a second. The way healthcare uses AI, artificial intelligence, it's predicted to surge by almost 30% just in the next year.
Wow, 30%.
Yeah, and the money involved globally expected to jump by 40%. That's not some far off thing. It's happening like right now.
It really is. And it's definitely set to change how we all might experience healthcare down the line.
Exactly. And that's why we wanted to take a deep dive today into one specific area where it's really making waves, urology.
Right. And the research you brought is, well, it's fascinating because it shows how AI isn't just a buzzword anymore. It's actually becoming, real tools in this field.
Yeah, we've got this really insightful review article. It's from the Turkish Journal of Urology back in 2020.
Okay.
It's called Artificial Intelligence, AI, in Urology Current Use and Future Directions, an iTree study. It's pretty comprehensive, gives a good look at the research happening.
And so for everyone listening, we've sort of done the heavy lifting, haven't we? We've pulled out the most, let's say, compelling bits.
Yeah, the really important ways AI is being used right now, and how it could totally change things in urology. Diagnosis, treatment, predicting outcomes, all that stuff.
We're aiming for those aha
Yeah.
moments, hopefully, without getting too lost in the super technical jargon.
Right. So our mission today, basically unpack how AI is shifting things in urology now and explore the, frankly, incredible possibilities for the future. Ready to jump in?
Let's do it. Now, before we get into specific conditions, it might help just to quickly touch on the main types of AI being used here.
Okay, good idea. A quick overview of the key approaches.
Yeah, the review points out four main ones that keep popping up in healthcare.
Yeah.
First, there's machine learning, ML.
Okay, ML.
Think of it like teaching a computer to see patterns in loads of data. You show it examples, it learns to recognize stuff.
Like learning by example, basically.
Exactly. Then there's natural language processing, NLP.
Right.
That's all about computers understanding, well, human language, like reading doctor's notes or reports.
Got it. NLP for language.
Then you have deep learning, DL, and artificial neural networks, ANNs. These are, let's say, a bit more complex. They use layers, kind of like a brain network, to learn really intricate patterns from massive data sets.
Okay, more advanced pattern finding.
Yeah. And finally, computer vision. This lets computers see and interpret images. Think medical scans, videos from surgery, that kind of thing.
Right, so ML learns patterns, NLP does language, DL and ANNs are like complex, brain-like learners, and computer vision sees images. Makes sense.
The article even mentions a figure, a diagram showing how they build these models. It looks complicated, sure, but we're focusing on what they do, right?
Exactly. Let's get to the applications. That's where it gets really interesting.
Totally. And we see that when we look at how these tools are tackling specific urology problems. Let's start with kidney stones. Urolithiasis.
Ah, yes. Kidney stones. Heard they're not fun. What's AI doing there?
Well, things are moving really fast, actually. AI is being used pretty much across the board, starting with just, finding the stones on CT and ultrasound scans.
Okay, just spotting them.
Yeah, like one study, Parak and his team used a type of deep learning CNNs and got over 90% accuracy finding stones on CTs.
Wow, over 90%. That could speed up diagnosis quite a bit, couldn't it?
It really could. And it doesn't stop there. AI can even help guess what the stone's made of.
Really? How?
Kazemi and colleagues, they used what's called an ensemble model, sort of like combining different AI models, and hit 97.1% accuracy predicting the stone type.
97.1%. That's amazing. And knowing the type is important for treatment, right?
Exactly. Because some types might dissolve with medicine, others need, procedures. It makes a huge difference.
Makes perfect sense.
And, for patients maybe hoping to avoid surgery, AI is even trying to predict if a stone will pass on its own.
Oh, interesting. How accurate is that?
Dalmora's team used a machine learning method, PSVM I think it was, and got about 85% sensitivity and nearly 87% specificity. So pretty good odds for predicting spontaneous passage.
So AI could help with that wait and see versus let's intervene decision. That seems really valuable.
Definitely helps manage expectations and guide choices. And it goes further, even predicting how well surgery might go.
Like for stone removal surgery.
Yeah, exactly. Shabanian's group looked at PCNL, that's a minimally invasive surgery for bigger stones, and reported almost 95% accuracy in predicting the overall success.
95%. That's huge for planning.
It is. They can even predict things like needing a stent or a transfusion with good accuracy. Helps surgeons and patients prepare,
Absolutely. That's fantastic insight to have beforehand.
For sure. Ayman Sharifi's team also got similar results for PCNL outcomes. showing their AI model was as good as, maybe even better than, some standard prediction tools.
So it's really holding its own.
It seems so. And here's a really cool bit. Kriegshauser and colleagues used a special CT scan, dual energy CT, with AI.
Okay.
And they could tell the difference between uric acid stones with 97% accuracy and other types with pretty decent accuracy, too.
Whoa, so they could potentially figure out the stone type without removing it first.
That's the potential, yeah. Hints at, future non-invasive ways to diagnose stone composition, a possible game changer.
That is genuinely cool. Okay, AI is clearly doing a lot for kidney stones.
Yeah.
What about another really common thing, BPH, benign prostatic hyperplasia?
Right, BPH, the enlarged prostate.
Yeah.
That's another area where AI is showing promise. The paper mentions that, well, sometimes the current ways to predict how severe someone's BPH is aren't always super reliable.
Yeah, I've heard it can be hard to tell how much it's actually affecting someone's life just from the basic tests.
Exactly. So researchers are using AI like fuzzy systems and ANNs, those artificial neural networks, again, to try and get a better handle on BPH severity.
Fuzzy systems, what does that mean?
Think of it like AI that's good at dealing with uncertainty or fuzziness in medical data, not just black and white answers. Torshitsi's team used one and got around 90% accuracy predicting severity and even suggesting treatments.
Huh, a fuzzy system. Sounds like it fits well for conditions that have shades of gray.
It kind of does, yeah.
Yeah.
And Sonkate's group also used ANNs for diagnosing BPH, comparing it to standard stats, and got, decent results too. Shows AI's potential as another tool for diagnosis.
Okay, interesting. Let's switch gears a bit. What about kids? Pediatric urology. How's AI being used there?
Yeah, this is a really positive area.
Mm-hmm.
AI is helping predict surgical outcomes in children. For instance, Bogley and his team looked at pyeloplasty, that's surgery for a kidney blockage.
Right.
Using ANNs based on ultrasound results, they reported, 100% sensitivity and specificity in predicting success.
100%. Seriously, that must be incredibly reassuring for parents and surgeons.
You'd think so. That kind of accuracy is amazing for planning and just, peace of mind.
Definitely.
AI is also being looked at for finding abnormalities in kids' imaging. But it's important to note, AI also helps us see the limits of current methods.
Yeah.
Well, one study by Logvinenko found that standard kidney and bladder ultrasounds weren't actually great predictors of problems found on a more complex X-ray, the VCUG. So AI isn't always the magic bullet, but it helps refine our understanding. It shows us what our tests can and maybe can't reliably tell us.
That's a really good point. It sharpens our existing knowledge, not just replaces it.
Exactly. And speaking of predictions, Blom's team used machine learning based on kidney scan dynamics to predict who might need surgery for a certain blockage, UPJO. They got 93% accuracy.
93%. So helping identify earlier which kids really need the operation.
Precisely. Potentially avoiding delays or later complications.
Makes sense. Now, what about urology issues more specific to women? Urogynecology.
Yeah, in urogynecology, AI is being used in some pretty clever ways, like with all the wearable tech now.
Oh, yeah.
AI is analyzing data from those devices to try and predict urinary incontinence episodes.
Wow. Like a sort of early warning system based on your own body's data?
Kinda, yeah. Could really help people manage things proactively, give them more control, improve quality of life.
That sounds incredibly useful.
Definitely. And there are also AI models predicting potential problems after surgery, like stress incontinence following prolapse repair. Savadell's group worked on that.
Predicting complications, okay.
And Jolovsik's team looked at predicting overall surgical outcomes, too. The big idea here is moving towards really personalized care, analyzing your specific data to tailor treatment and maybe even anticipate issues.
That really feels like the future, doesn't it? More preventative, more individual. Okay, one more benign area mentioned. Renal transplant. Kidney transplants.
Right. Predicting how well a transplanted kidney will do, how long it might last, obviously super important.
Oh, crucial.
So several studies are using ANNs and machine learning for this. Atala's group, for instance, combined a couple of methods, Bayesian and k-nearest neighbor, and got over 80% accuracy predicting 5-year graft survival.
Over 80% for 5 years out? That's pretty significant for planning long-term care.
It really is. Gives patients and doctors a much better picture. Greco's team used decision trees, another AI type, to predict graft failure, finding links to things like BMI. And Atala's approach was quite detailed, prepare the data carefully, pick the most important factors, then predict. Suggests a really thorough way AI can help improve transplant success.
It sounds like AI is becoming a really versatile tool across all these non-cancer related urology areas.
It certainly seems that way.
Okay, so now let's turn to the more serious side. Uro-oncology, cancers of the urinary system. Where's AI fitting in there?
Right, uro-oncology. Here, AI is being explored for, well, pretty much everything.
Hmm.
Improving diagnosis, predicting treatment response, survival chances, the whole spectrum.
Okay, where should we start?
Let's start with testicular cancer. The review notes there's maybe less research here compared to others, but it's emerging.
Okay.
Baszler and colleagues use machine learning on CT scan, feature something called radiomics, looking at subtle image textures.
Radiomics, right.
And they could classify lymph nodes in metastatic testicular cancer patients as cancers or not, with 81% accuracy, good sensitivity and specificity too.
So potentially helping figure out how far the cancer has spread more accurately, guiding treatment.
That's the general idea, yeah. Finding patterns the human eye might miss in the scans. Now, moving to kidney cancer, renal cell carcinoma, RCC, there's a lot more going on there.
Okay, RCC.
AI is really being used to tell different types of kidney masses apart. Some are benign, like angiomyolipomas. Others are cancerous, like clear cell or papillary RCC. AI analyzes CT textures to help differentiate them.
So going beyond just how it looks overall, digging into the image details for a better diagnosis?
Exactly. Studies by Kokak, Fang, Coy, they've all shown promise there.
Yeah.
And it's not just what type of tumor it is. AI is also predicting the grade of the cancer.
The grade meaning how aggressive it looks.
Precisely, how aggressive the cells appear.
Oh.
Kokak's team hit over 85% accuracy, classifying the grade of clear cell RCC using AI. That's really important info for deciding on treatment.
Wow, pulling that level of detail from a scan is pretty impressive.
It is. And they're even using AI with gene expression data, looking at which genes are active in the tumor to predict survival and prognosis. Lai's group developed a 15-gene model for RCC.
Gene data too, okay.
And get this, another study by Kokak's team used AI on CT scans to actually identify mutations in a specific gene, PBRM1, which is often mutated in clear cell RCC.
Wait, identify a gene mutation from a CT scan?
Yeah. With 88% accuracy using ANNs, it suggests maybe, in the future, we could get genetic insights without needing a biopsy sometimes.
That would be a massive shift, getting genetic info non-invasively. Okay, what about bladder cancer?
Bladder cancer, another major area. A key thing here is improving cystoscopy that's using the camera scoop inside the bladder.
Right, looking for tumors.
AI, especially CNNs, is proving really good at helping spot potential cancers in those cystoscopy images. Think of it like an expert assistant for the urologist.
So catching things that might be subtle or easily missed?
That's the idea. Akida's study showed nearly 90% sensitivity and 94% specificity. Lorenzen's work also showed really high performance, like AUCs up to 0.99, which is almost perfect classification.
That's incredibly accurate.
It is. And AI is also being used after diagnosis to predict how patients will do after surgery, like radical cystectomy, removal of the bladder. Wang's group got over 75% accuracy there.
That kind of prediction must be so important for patients facing that big surgery.
Absolutely. And other machine learning models, like from Gabriel and Hasnain, are predicting the chances of the cancer coming back after surgery, often with really high accuracy, sometimes over 90%.
Predicting recurrence, okay.
And interestingly, it's also being combined with genetics again. Barch's team used AI and gene profiles to predict recurrence of non-muscle invasive bladder cancer. And Wu's team used deep learning to predict response to specific treatments.
So again, pushing towards more personalized treatment strategies based on the individual and their specific cancer.
Exactly. It's a recurring theme, using AI to tailor the whole journey, from diagnosis right through treatment and follow-up.
It's amazing. No, we definitely have to talk about prostate cancer, right? A huge area in urology.
Absolutely. Prostate cancer is, well, probably one of the biggest focus areas for AI in urology. The potential impact on diagnosis, treatment decisions, predicting long-term survival. It's massive.
Okay, where is it making the biggest difference so far?
One key area is Gleason grading from biopsies. That's how pathologists score aggressiveness, but there can be some, variability between observers.
Right, different pathologists might grade slightly differently sometimes.
Exactly. But AI models, like from Strom and Bolton, are showing really high accuracy, like Strom's had a 0.997 AUC distinguishing benign from malignant, and Bolton's had high accuracy for grading groups. AI can make grading more consistent, more reliable.
So a more objective assessment of aggressiveness, that would definitely impact treatment choices.
Hugely. AI is also being used a lot with advanced imaging, like MRI, for computer-aided diagnosis, helping doctors spot suspicious areas better.
Okay.
And check out these specifics. Deng's group built an AI model to help stratify treatment for advanced castrate-resistant prostate cancer, basically identifying who's likely to tolerate a specific chemo, docetaxel, and who might not.
Wow. Predicting tolerance to chemo, that avoids unnecessary toxicity for some.
Potentially, yeah.
Yeah.
And Delica's team used AI for automated biomarker analysis in tissue samples, getting 100% accuracy identifying a specific marker, ERG plus cheese. That helps understand the tumor better.
Biomarker analysis, too. It's really digging deep into the specifics of the cancer.
It really is. And finally, Bybelt and colleagues, they developed an AI algorithm predicting 10-year cancer-specific survival with 98% accuracy.
98% for 10-year survival.
Yeah, and 87% for overall survival. They even suggest these could become online tools to help doctors and patients make decisions together.
That's honestly incredible. Having that kind of predictive power readily available would be a game changer for planning and discussions.
It's a really exciting prospect. But, it's important to remember, despite all this amazing progress, it's not quite plug and play yet for everyday clinical use.
Right. There are still hurdles, aren't there? It's not just about having the cool algorithms.
Exactly. The review article stresses the need for, well, more standardization. How data is collected, how scans are done, different hospitals, different machines. It can affect how well the AI works.
So the AI trained in one place might not work perfectly somewhere else.
Precisely. We need data from lots of different places, multi-institutional data, to make sure these AI tools are robust, generalizable, make sure they work reliably everywhere. Jen's group pointed this out.
That makes sense. You need diverse training data for diverse real-world use.
Yeah. And looking ahead, the focus needs to be on building bigger, better medical databases, refining the algorithms constantly, and making the tools easy for doctors to actually use, maybe even on tablets or phones eventually.
And getting regulatory approval too, I imagine?
Oh, absolutely. Getting the official permissions, making sure they're safe, reliable, addressing any concerns about bias. That's all crucial.
So it's a journey involving tech, data, standards, and regulations.
It really is.
Well, this has been truly fascinating. To sort of wrap it up, it's clear AI isn't just science fiction in urology anymore, is it?
Not at all. It's actively being used, making real strides across so many conditions, from finding kidney stones better to predicting cancer outcomes years down the line.
Yeah. And for everyone listening, the so what is, well, this AI progress could mean more accurate diagnoses for you or your family, maybe less invasive procedures sometimes, treatments that are really tailored to the individual, and hopefully better health outcomes overall in urology.
That's the goal. Absolutely.
So as AI gets woven more and more into healthcare, into urology, here's maybe a final thought to chew on. How do we best blend the amazing power and precision of these AI tools with that essential human touch? The empathy, the clinical judgment that's so vital in taking care of patients. That's the big question, isn't it? Finding that perfect balance.
Definitely something to keep thinking about as this field keeps charging ahead.